Anybody want to add topics, or you want to look at the still in review docs? What do we want to do? Or carryovers?
So are those two still being reviewed? Is there any update on the OSCE policy? Louis and John, I think that's maybe more interesting because the last time when we were discussing the target OSCE policy, both of you mentioned you want to redesign it.
Yeah, you were out last week, right, for a chunk. And then John sent me a doc yesterday evening, which I'm currently going through and commenting on. I don't know, John, if you think it's a little premature to get into the weeds on that one, or what do you want to do?
If we have nothing else to talk about, I suppose we could. I didn't initially intend to do it this week, probably next week, but we could.
Yeah, I suspect might want to have some iteration before we jump off that diving board.
Okay, that's fine. Yeah.
I mean, if there's nothing else to do, then sure. But I think we might want to give some other stuff a chance to get some breathing room before we go down that rabbit hole.
Yeah. On this layer policy attachment thing, it says I'm out of office, so there's no progress yet. Is it blocked on me? If so, I didn't realize that, so I should go do something. I thought I had approved it. I'm the only approver on it, so I think it's actually blocked on the other TOC members.
No. We're talking about the design, not the PR in the API repo, right?
Yeah, I'm talking about this layer target OSCE policy, which is also this first field.
Right. So the policy attachment redesign, that's blocked by you, right? Because you and Louis took a to-do for that. The layered target OSCE policy, I thought it's already approved on the API repo.
No, that one doesn't. I think we're mixing the protocol field and the target ref. The target ref stuff is merged, and I mean, there may be a few implementation PRs for the different APIs still in flight, but that's mostly done or in progress. It's just this one about the protocol field in authorization policy.
Oh, okay. I missed that one. Okay, I thought it was only for the ref one. Okay.
What did you say the remaining things were, John? Sorry, target ref?
No, target ref is either, I mean, the API is approved and there's maybe some open PRs that just need to be iterated on implementation. Nothing controversial. It's just pure implementation. But there's this protocol field inside of authorization policy. Or the layer, whatever we decide to call it. That needs the design doc approved. There's no PRs yet for it.
Okay. Hopefully I reasonably captured those notes. The other one, the per pod DNS, right? That's resolved, right?
Yeah, we decided to defer that. So
yeah,
no more action item there.
Okay, let's capture that. Okay. Is there anything carrying over from last week's? Okay, policy attachment design. The sandwich. Is Stephen here?
Yeah.
Stephen, maybe you want to talk, is there anything to talk about on the sandwich side?
Yeah, I think we kind of thought a little bit more about propagating identity. As you see your comment, John. Like, yeah, so looking back at an old doc that Louis had sent me called like Ambient Metadata, this doc like there's a handful of suggestions on different ways to propagate information from ztunnel to, I guess this is talking more about applications, but in this case, the waypoint would really be that application. And proxy protocol seems like the simplest thing to implement this with, where we can, we're likely going to want to use proxy protocol anyway, because it helps us propagate source and destination information between the ztunnel and waypoint. And then additionally using the suggestion of sending like type blank value headers to send the identity over. And then ztunnel would have to, sorry, waypoint would need to know to read those headers and use those as the identity. So we could just send the spiffy ID over, we could send the client cert over. I think there's those suggestions in that doc as well. Assuming that the channel between ztunnel and the waypoint is confidential. So either like MTLS or UDS. And so that's kind of what I've been looking into this week, or pretty much since yesterday, for propagating identity into the waypoint with a sandwich. The main thing I don't like about this is the fact that it's like kind of a yet another kind of new protocol type thing that kind of takes away one of the benefits of sandwiches. Like, you know, you can factor out H-bone into the ztunnel, so that, you know, you don't have to re-implement H-bone, and we just like layer that in. But now you have this new protocol, which kind of takes away some of the benefits of being able to just like bring in a new custom application to be your waypoint proxy.
Can you explain a bit? I mean, why does it take the advantage away?
Because now whatever thing you bring in needs to implement this new thing where it needs to know to read these headers, which is maybe not as hard as implementing H-bone. Not that implementing H-bone is necessarily that hard.
But pretty much everyone supports AG proxy. I mean, it's required by many clouds. It's not something that we are the only ones.
It's not just being able to like read these headers. It's about knowing to use these headers for the purpose that we want to use them for.
It's also because for proxy, it's inline in the protocol. There has to be an agreement between the client and server to do it. So how do you actually go roll that out? You can't really, I mean, it's tough to say like the application goes and adds proxy support, somehow indicates it, and then we make sure that we never have any period of downtime where we're sending it or not sending it. The other two approaches in the doc, in my opinion, are dramatically better because they're not actually part of the main wire protocol. They're kind of side channels. So the application doesn't, the two ends don't need to agree, right? If the application adds support for reading it, they can do that, and they don't have to tell the proxy to start sending some different information. But any approach is going to need application changes. Like, it's not like there's a existing standard that all applications are already reading from some magic place to get identity. But it is a big difference, I think, if they have to, you know, actually change what they're accepting or just change how they're processing. If that makes sense.
One thing I want to make sure we agree is that there is not one solution that we need to pick out of the others that is somehow better than the others. We will probably need to support multiple mechanisms and to deal with multiple applications. And if an application really wants to know the peer identities, they need to do something. There is no way they can just magically get it and know it. Even with current Istio, they need to parse some weird headers that is specific to Envoy and not very well documented. So some code changes if you want to get the peer identity is required no matter what. Now, there are plenty of applications using SGI proxy because it's broadly used in multiple clouds. So it's not, yes, if you want some Istio specific headers, you need to read them, but I don't think we need to go back to the mode where we choose one single protocol and with extra requirements that no application should ever be modified and magic should happen. We can probably support all of them, all the options that are on the document.
Okay, so I mean, proxy protocol works. It's relatively straightforward to implement. I agree with Costin, right? We're probably going to have to support more than one mechanism down the road. There's kind of two mechanisms here, right? Inline or out of band, right? We'll probably have to support both kinds. Proxy protocol will work for inline TCP. It won't work for inline UDP if and when we support UDP. So we'll have to look for something to support that over time anyway. And maybe that will have to depend on the out of band mechanism to do it, or something else, right, at lower level. But on the other hand, proxy protocol is pretty widely supported. So this would enable a decent number of people to get going if they cared about getting going with some other implementation. And no matter what you do, whether it's in band or out of band, if you want to use this information, you have to change your code fundamentally, right? Like there's no, right? Most applications don't use pure metadata. Whether you're gRPC, Envoy, or something else, you're going to have to adapt if you want to take advantage of this. So I don't think there's a problem. Oh, like that's what we're trying to do, right? So we're going to make that happen. The question is just the choice of mechanism, and do we have to make a definitive choice now, or can we support multiple mechanisms down the road?
One thing on the application versus waypoint, I think the waypoints are actually unique in that the application just need the source identity really, and maybe metadata, although it seems like we're moving towards the discovery service for that. But waypoints they have the destination IP address and the host header are different. So we need to retain that somehow. I'm guessing that's doable in proxy protocol. But we should make sure we take that into account.
Yeah, that part I think.
Yeah, looks like they have desks.
Yeah, they have desks. Yeah,
okay.
Like that's part of the reason why proxy protocol exists.
Yep.
So
cool.
But proxy protocol is one way, by the way. It's just, you know, it's in one direction. So the server gets information from the proxy, but we still need the opposite. And what John is saying, I half agree with him. So we need a way to propagate the original intent of the application, be it original service VIP, original pod IP, or FQDN, if possible, so we can resolve the dependency on DNS. And I think SOX is the standard protocol. I'm happy with any other protocol, but it's not only for waypoint, but also for any kind of applications that needs to go through whatever, you know. So we need to preserve the source, the source original destination, basically.
Yeah, proxy protocol definitely preserves original destination as IP.
No, Louis, it's the other way. I mean, when you receive a request with AJ proxy with the proxy protocol, you can get the client IP, but there is no way for a client to indicate and to propagate its own, unless you implement client-side proxy protocol, maybe, but I haven't seen it used.
Why do we need this? What's the use case?
What you said above about how do you preserve the source original destination, and if your application wants to send the original domain name, so we don't depend on DNS being accurate.
Yeah, I was actually talking about the Z-tunnel to waypoint hop. I think you're talking about the app to Z-tunnel hop.
Up to Z-tunnel, yes, and Z-tunnel to whatever, you know, other waypoint proxy gateways or anything that's it.
Yeah.
Do we have does any Istio feature have a dependency on source IP preservation post waypoint right now?
Well, depends on how you treat DNS. I mean, if we continue to depend on DNS security.
I thought that's before waypoint, not after.
Before waypoint, yes, that was the first hope.
Yeah, so like source IP preservation is an after waypoint concern, Austin.
Yeah, I'm talking about the intent of the application of I want to talk with this particular service. If we continue to express it only as a VIP, then it's fine.
Right, but so like source IP preservation, like when you don't get that, say, with most reverse proxies other than X forwarded for, right, when you talk to service. It's only when you talk to workload that it might matter.
Yes.
But we don't have a feature in Istio today that's dependent on source IP preservation. Really. I get what you're saying. It's just hard to think of a policy that would be dependent on it.
It's more complicated. There are people who are running, with T-proxy and because if we want to not modify the behavioral application compared with, basically it's the impersonation of the IP, so what we are doing even today. So you don't have any Istio, you have source talking with destination, both of them sees each other IP. We want to preserve it with Istio somehow, no?
Certainly we do that with ztunnel, that's correct, right? We're not doing it when we go through. A sandwiched waypoint currently doesn't do this.
It should.
It could. And it probably, I think it's debatable about whether it should. Right, the one thing about having HBone inline in Envoy was it was easier to do that. Right, because we could put the original source IP into the header in the connect request. I don't know if we're strictly blocked on that though. Right, so this is a trade-off, I guess. Okay, let me capture that in the notes. I think we probably need to think about that.
So assuming we do support more than one approach, I mean, kind of like Quad is suggesting that these have different requirements, applications might have different requirements. Is it possible that we have some way that something can indicate that for inbound propagation, it wants to use proxy protocol and it supports it? In this case, we can have our waypoint indicate that and use this because it's easy to run towards now. And yeah.
I think we have a label or something that's like supported protocols, and today it's just as HBone, but we've made all the code treat it as a list. Maybe, so we may be able to reuse that. It's like a label on the pod, so.
Yeah, I don't think it would be something like I have a waypoint, so always do proxy protocol. It would be something more specific like that.
Or other.
Can you elaborate, Quat?
Well, if you're going to support sandwich, I think you're trying to extend the range of applications that can integrate. And we are limited to TCP. And if you replace it with HTTP connect with proxy, you're not really changing that. You're just changing the details. While it's better to focus on actually improving the supported range of protocols rather than just shuffle TCP protocols.
Quad, for UDP, we'll have a separate discussion. I don't think UDP and TCP, I mean, we'll support multiple protocols for sure. And what we do for UDP is a very complicated story because there are all kinds of UDPs. There's not only one plain text UDP is not so popular anymore. So there is UDP that's already encrypted. Let's not mix UDP with the rest.
So we could just document the limitations, right, and say, look, if you're a waypoint that's integrated via proxy protocol, here are the things you can and cannot do. If you're a waypoint integrated by SOCKS, here's what you can and cannot do. Or an application, right? Whatever is the bump in the wire. If you're integrated via HBone, here's what you can and cannot do. Right, and that would incorporate Connect UDP and others. Cool. I'm going to say that TLVs are actually quite widely adopted, and Google has even standardized one. I'll provide you a link.
Yeah, but I looked at the implementation of the L7
Oh,
DBs, they are not doing TLV parsing.
Where the hell was it?
I mean, there is another problem with TLV proxies. It's single direction, I think. You can't send stuff back. It's like
Yeah,
fundamental.
so right, one of the limitations would be right the somewhat unidirectionality of it.
Yeah, right, and it's somewhat a deal breaker, I think, because it's never going to be full solution. You have to do something else to get stuff back. I mean, Envoy supports TLVs, Nginx support TLVs. It's not that. It's that the proxy protocol are parsed by non-proxies. They're parsed through eBPF sometimes, and other low-level infrastructure, and those ignore TLVs.
Yeah, I mean, like we don't control the entire networking ecosystem, right? Not everybody implements standards the same way. There are limitations to what we can take on. By the way, if you look at the link that I sent, the examples that are in there are all identity passing, effectively. I think our decision,
right? I mean, the infrastructure identity passing, right? The something that's the LBs that cloud provides. They put stuff in there, right?
yeah, I mean,
represent LB.
There are identities, right? Whether they're fine-grained or coarse-grained, right? They're there for a reason, right? So people can write policy against them. Right, and obviously, like those have the same set of limitations with other parsers of proxy protocol, right? Anyway, I think our choice is right now is fairly narrow. Like we'll probably have to support more than a couple, right? We already support SOCKS and tproxy, right? Is sandwiching going to yield us compositional benefit and efficiency benefit, right, from an implementation and supportability standpoint?
So I'm not 100% certain that I understand the concept of sandwiching versus some of the other sort of topologies that we've discussed. I learned graphically, and I'm wondering if it would be possible. Actually, well, John, if you're raising your hand, I'll probably understand it when you're done talking. Go ahead.
My hand was actually to respond to Louis, but I'll respond to you first and then to Louis. So the idea of sandwiches, your application, it doesn't do TLS, right? It uses the waypoint. Oh, someone has a picture. Perfect. All the traffic goes through the waypoints, right? That's how your app works. That's how apps have always worked. Now with the waypoint, we said, forget that. Waypoint's not involved with ztunnel. It's going to handle all the responsibility of ztunnel in itself. So the sandwich is saying, no, we'll treat waypoint as just a normal application. All the traffic will go through a ztunnel. And so we can offload some of the responsibility of the waypoint into the ztunnel. Now, there's also some discussion of doing the same for even sidecars. And if we say, we make the sidecar do even less, and we have a ztunnel involved there. So you go application to sidecar to ztunnel. So I don't know. We were talking about different flavors of sandwiches earlier, I think. So there's kind of different varieties, but really it means that ztunnel is involved in the application.
And then the waypoint doesn't need to be aware of whatever the layer 4 protocols are, HBone, et cetera. You can be completely agnostic of that.
Yeah, well, it does need some protocol between ztunnel itself, so it's kind of
it needs to
bring back a protocol, but yeah.
Right, that's why it's an implementation complexity choice, Mitch. Right, like Waypoint has to know something to take
Right.
advantage of the extra bits that zTunnel is giving it on top of the basic network. And can we do that simply and cheaply?
Okay, thank you. That's very helpful. I like the pictures.
Yeah, thanks for the picture as well. I'm a bit concerned about the cheap part. Like we've known that with Sidecar it's a trade-off of application flexibility versus performance. But we don't need the application flexibility in our own application, right? So if it was cheap, then, or if it is cheap, then it's great. But I'm just not necessarily sure that it's cheap enough at this point to push that performance implication onto the user. Although it may be simpler. Well, it's simpler in some ways, more complicated in different ways. So it's tricky. I'm not against it necessarily, but we should be cautious and make sure we get numbers and whatnot. Unfortunately, I have to drop, so I'm going to leave that comment and run.
Okay. Well, I'll respond to John's comment, but he can run anyway because he's not going to. I'm not going to say anything he doesn't already know.
Okay. Bye.
Right. So the performance concern is real. Right. So that, like these are just classic implementation trade-offs for us. The other part is the composability part. Right. The ability for the Z and the W to evolve at different rates, and what that means for maintenance, upgrade cycles, yada yada. And then the last one was the vendorization, where the W is not a W, the W is a V. Right. Or a W prime, or WXYZ. Right. That's the other thing. And that's what Stephen is looking at. Stephen, do you want to? Like when we talk about complexity, right? Specifically our own. Often what we use as a benchmark for complexity is like, how crazy is the Envoy config? Right. I don't think we yet have performance numbers. Or Stephen, I don't know if you do.
Not once we add any of this. Like propagating identity. I have some performance numbers where we don't have the identity and don't do a lot of the work.
Yeah, so I think a question here is, if the complexity is a wash and the performance is a wash, but we get the composability and the separate evolution cycles, then it's an interesting decision, right? If the performance is, or even if the performance is slightly worse, even, right? How much do we value composability and kind of separate lifecycle versus, right? So trade-offs.
I mean, in terms of like, sorry, go ahead.
I know, go ahead, Stephen.
Like in terms of like Envoy config complexity, the like internal listener stuff, the performance doesn't really end up being awful. And if you like, it's kind of like if you think that internal listeners are more complicated and harder to understand than having some Envoy filter or like custom network filter written that parses special TLDs, like one of them looks more complex if you're just reading your Envoy config, but one of them is more complex in the fact that you have to compile stuff into the proxy. So I think like the complexity thing is a bit subjective. I don't think either is necessarily much better or much worse.
Okay, so we could say complexity is a wash, maybe a little bit useful, like probably get some other subjective assessments of it by a few different folks. Performance, and then composability. Like the one thing that I think we all liked on the composability side is, right, if there was going to be a zTunnel prime, right, it might be easier to roll that out if these were composable units rather than if they were bundled. But we don't have signal about that from production because we don't have any signal from production, right? So.
Louis, how do you feel about still doing some of the SNI sniffing that we did in the past for the East-West Gateway and other things in the case of applications? I mean, that my primary concern is applications that are not actually dumb and use plain text HTTP, but they are using frameworks and stuff that have built-in MTLS, and they basically have everything done right. Would it be possible to support them naturally, so we don't do any extra encryption, we just let them through and because for example, I mean, it's just we do TLS in the pod and
I guess there's a few different parts of that question, right? The first one is, if you already have a sophisticated framework, what you need like service mesh for, right? Is that answer somewhat flippant, but actually real? Like if you're using gRPC, right? And it's doing a great job with TLS and telemetry and all those other things. Then there's, just zTunnel with no waypoints. And you probably don't care because zTunnel is dumb and the overhead is marginal. And yeah, maybe we could sniff TLS and pass it through, right? But we're talking about percentage point differences in the low numbers. So maybe not a priority. And then there's waypoints, right? Like if clients and servers are doing their own MTLS or their own TLS plus JOTS, what should waypoints do?
Policy, enforcement policy, you cannot do it otherwise because, you don't trust the ends.
Right, which you're reduced to L4 policies at that point, right? Like we're not going to do, sorry, I'm going to not use.
Not if you terminate in the waypoint. I mean, waypoint as gateway, like we were saying before. I mean, you have.
But then there has to be some agreement with the client application, right? It has to agree on the certificates. And there, I think you would just use the gateway API and TLS termination like directly as an application level facility, right? And we would just evolve the gateway API along those lines.
Absolutely. It's part of the same, same mesh.
So it's a service.
Yes.
So there, then it's just the optimization question, right? Are we layering or not layering? And if the performance delta is marginal, I'd say let's start with layering, and then we can figure out if we can delayer it later. Because zTunnel is fast, right? And hopefully only going to get faster. So 2 TLSs for the price of 1 for a while. Seems like it's an okay choice.
Yeah, one thing worth highlighting is I think the other value of composable is whatever we need to do across different network. What if we want to implement something like double Edgebow, right? That composable really allow us to leverage this to do it so much easier. That comes with the sandwich.
Lynn, can you explain what double H-bone is?
So you would have like Edgebow not only on your outer layer, but also potentially on your inner layer, right? So typically you may want to add for added security when you need to go cross network or cross clusters. Oh, Stephen has a doc. Thank you.
Thanks, Stephen.
Yeah, I do remember John had a doc on that.
Yeah, typically when you cross an infrastructural boundary, not an application boundary, right? But you want to preserve the internal application semantics, you end up in some form of double NCAP. Right, like take 2 VPCs. VPCs internally have their own NCAP, and then you connect them via, let's say, a VPN tunnel. That VPN tunnel uses IPsec. You end up with double NCAP. Same kind of idea. And you can't, right? The infrastructure bridging doesn't know about the application identity, so it has to use its own identity to do the NCAP, right? And so you end up with the application identity nested inside the infrastructural identity. Super common. And the proposal was to do that for east-west gateways because, well, that's an infrastructural concern. And what Istio did with kind of SNI routing at east-west gateway you could maybe make an argument that there's some security issues with it, right? Because the destination service is in plain text and therefore, right, might be subject to some form of attack.
And there is no zero trust because there is no authentication of the boundary.
Yes, the boundary
Yeah.
does not authenticate.
Zero trust is super important for policies and a lot of other things.
Yes. Layered
Yeah.
trust in this case. Zero trust end-to-end and infrastructural trust between bridging points. I don't know, Lynn, though, that
I mean, if you use the
Sandwiching-
sandwich for
Sandwich-
east-west gateway, would that be able to provide you that potentially double H-bone where your waypoint can do one H-bone and then leverage the Z tunnel, co-located Z tunnel to provide the second sandwich?
so you're talking about like a Z tunnel on Z tunnel sandwich?
I'm sorry, I shouldn't say second. I'm talking about a Z tunnel on waypoint where that waypoint already can do one H-bone and then the Z tunnel can provide the second H-bone.
Yeah, then it's like we've lost the simplicity benefit we were potentially lost the
Right,
simplicity
in that
benefit we were
case,
looking.
you would lose it, but at least it's you could leverage, the sandwich for double H-bone. Yeah.
I suspect we'd be better off having Z tunnel be able to act as the east-west gateway and understand how to process double H-bone.
Okay. I guess that's another option too. Yeah.
I'm not entirely sure that double H-bone is completely justified or required. I mean, you can have east-west gateway and everything with single layer H-bone just fine. I mean, it's not, or even with regular gateways with JOTs. I mean, it's not. We don't need to complicate things with triple framing and all the other stuff.
I think there's a variety of layered end caps that are probably okay, Costin. Like double H-bone is clearly okay, right? It may be overkill, I think is what you're saying.
Overkill, not necessary and not standard. I mean, if we just try to use standard components, I mean, let's say you take AJ proxy, you take a Squid proxy or any enterprise egress server, you take any regular ingress gateway, we should try to work with existing infrastructure and existing
Right,
tools
so-
and protocols, not to invent new ones.
If we took the kind of layered security concern out, like you could also say, like H-bone inside of proxy protocol would be valid. Right? Because the outer proxy protocol would be routable through something and it's just forwarding TCP. And then the H-bone, right, with MTLS is end-to-end for zero trust.
I think that this is, can you use a standard component that is not Istio and substitute it to our component? I mean, if that's kind of the golden test for anything we are doing. I mean, if it's only Istio component that speaks that protocol or whatever it is, then probably is not good. If you can swap components, then probably it's
I think there are many components that can speak H-bone. Certainly speak HTTP connect.
Yes, absolutely. That's why it's a very good protocol. One or two. I mean, there's Squid, there's all enterprise egress gateways. Now, if we are moving to double H-bone, I want to see one component, one browser that supports it, and I'll be easy.
Well, no, remember this. We're not any of the gateways with double H-bone. We're trying to maintain end-to-end between the application and the service, right? So we don't want the middle box to terminate the inner, but it can certainly terminate the outer and process it.
That's very debatable if it's valuable or not, because if you don't terminate the inners, then what policies do you apply? I mean, you're very limited in policies. I mean,
you're applying
yes, maybe
you're a network bridge. You're not right an L7 reverse proxy. It's a different use case.
Yeah, the inner would be preserved, so you can send it to the waypoint, and the waypoint could make those decisions. And I think that's the idea behind it, right?
But yes, but then your policies are very limited, and if you want to be an enforcement point, probably you want to terminate and have access to apply normal L7 policies, or
right. But then you don't have don't use double H-bone at origination, right? You could use single, right? WH1 exists for network bridging, right? It's to look like an IPsec gateway with at least some hope that it's interoperable with more frequently used stuff, just like you would use for WebSocket.
So basically, it's a way to keep using MTLS, which is end-to-end with no middle boxes enforcing policies in multi-network. But my point is that in many cases, you want to have a real enforcement point in the middle that applies policies because you don't actually trust both ends.
Yeah, right. Then we would use single HBO.
Okay.
And
If
allow the
just
edge.
for this specific use case where you still want to do end-to-end MTLS for whatever reasons and with no delegations, then probably it's okay.
All right, so we went off a bit of a tangent there. Coming back to the sandwich. Well, I guess we'll just wait to hear back from Stephen about progress and simplicity and performance. And then, but people should be thinking about their composability and operation requirements, right? It's not just about the code.
So under the sandwich model, the contract between the waypoint and the Z-tunnel becomes standard TCP plus some extra for identity information. Is that right?
As close to that as we can get without making people pull their hair out. And probably offering some options just to realistically deal with the fact that to integrate into a variety of ecosystems, you might have to support more than one thing. Like SOCKS versus proxy protocol is an example. As well as HTTP Connect, which we have implemented.
I think what I like here is that it relieves the pressure for Istio to be everything that the network ever needs to do. If we're interoperable with other components in a standard way, and you like, well, I think Solo, you guys have what's Facebook's data-driven API REST standard, GraphQL. If you want GraphQL specific logic and you have a proxy that's great at doing GraphQL APIs, throw it in there. It doesn't need to be, Istio doesn't need to know GraphQL in order to make that a viable thing on your network. Otherwise, Istio becomes the kitchen sink, which is a problem we had at F5 over 20 years building the big IP. It gradually became the kitchen sink of the network because it had to do everything. There was no interoperability.
Feature or bug, Mitch?
Bug.
Okay, we'll let Stephen come back. We have something that works today. Hopefully we can have something simpler that works. Either way, and we're probably going to have some other things no matter what. Okay. Other topics.
What happens in the sandwich use case if the waypoint is co-located with the service?
Can you explain what you mean by co-located? Is in
It's like same node?
Same node, yeah.
Z-tunnel should do its optimizing the encryption path thing. Right, Z-tunnel would still have to send info to the waypoint, and the waypoint will have to send info back, which Z-tunnel will then decide how to physically route.
Okay, so it would still be the, let's see, client Z-tunnel calls server Z-tunnel, which calls the waypoint, which sends back to the server Z-tunnel, which then goes to the server itself.
Well, on the same node, it's all the same Z-tunnel, right? Logically.
Sure.
Right. So yes.
Okay, I just wasn't sure if waypoint and service would communicate directly somehow.
No, I don't think so.
No, yeah.
Okay.
Yeah, it's probably better to draw this diagram where the Z-tunnels are not like this diagram is a node diagram. It is not a container diagram.
A much easier way to understand it if you think that Z-tunnel is part of the CNI layer. So assuming that CNI takes care of all encryption, then it's just standard Kubernetes where you have some application running on a node. Networking layer is taking care of encryption and all the other stuff. We just add some extra information about identity, but it's no different than what would happen, today if you use security at the CNI layer.
Yeah, I guess that is a good argument maybe in favor of the sandwich, right? Because for Z-tunnel to short circuit anything, it doesn't want to be doing HBone internally, right? It doesn't need to. Whereas doing HBone inside the Envoy forces Z-tunnel to use HBone to talk to it.
Exactly, and the CNI layer can do whatever MTLS they choose. It's
Right.
can optimize it in hardware, can do whatever they want as long as they satisfy the requirements that they meet the same security requirements as MTLS.
Okay, Mitch, you've asked the best question of the day.
I specialize in non-expertise.
Well, we deeply appreciate it. Stephen, did that? I probably should capture that in the notes because that's an important point.
I think it would just work even the way it's been prototyped. Not 100% sure, but I'm 90% sure.
I mean, like doing HTTP connect over plain text is not that much worse than doing proxy protocol with TLV. But it's a slight argument in favor. So just think about it when you do some. I guess the point here is, if there's going to be any fast path complexity, we want it to be in Z-tunnel, not in Envoy.
Yeah. I really need a job.
Any other random acts of business?
Louis, there was another metaphor we were using for topology other than sandwich, but I just came back from vacation and my cache is still warming. Hairpin.
I'm gonna use that one for sure.
Hairpins. Oh God.
Yeah, those are another topic we have to talk about.
I don't want to open a can of worms and make this meeting go late, but I would love to understand what the difference is between hairpins and sandwiches.
Okay. A hairpin. There's a client that is not mesh aware, and it ends up sending traffic to a pod that is in the mesh. The pod will know, hey, this traffic is coming from something that has not applied any policy. I can't trust that a policy has been applied. What should I do with the traffic? My choices are A, allow the traffic, blanket. B, deny all of this type of traffic. Or C, send it somewhere where that policy, the policies that I want to be enforced will be enforced. And that C is the hairpin. The suggested hairpin is send it to the waypoint, which would then send it back to the same workload. That's certainly the most complex choice. Right? Choices A and B are much simpler. And so the question is, what is an acceptable choice? Did I do that justice? Anyone else want to chime in on that one?
Isn't it first sent back to the local Z tunnel, which then decides whether to send it to a waypoint or not?
Well, I was assuming it was going into the local Z tunnel when it came into the workload.
Yeah.
So
the Z tunnel is where that decision is made to hairpin or to pass through. If there's no waypoint, if there's no layer 7 enforcement point, then that's an easy decision. If there's no layer 7 policy, it's a less easy decision. Well, there might still be routing. Okay, never mind.
Well, you've ended up at a workload already, right? So you are routed, right? As the naive client would perceive things, right? It did a DNS lookup, got an SRV record, and talked to a workload. And so there's a variety of different ways of thinking about this, right? Treat the mesh like a network. If you're on the network, you can talk to other things on the network. If you're not, you can't. That would argue in favor of decision B, which is just deny the traffic. Right, or at least require somebody to write an explicit policy saying allow out of mesh traffic into this workload under some circumstance. Different type of policy.
Okay, that's very helpful. Thank you.
Actually, custom network policy, so Custom made the point, that's what network policy does. I would argue that's not what network policy does. Network policy, like, so treat mesh like, imagine mesh is a CNI. Network policy says, if for things that are on the network, enforce these behaviors. For things that are not on the network, shrug.
Deny. I mean, if you basically the policy will be same namespace allow. That's probably the easiest policy that most people will use.
Right, but
you have PostgreSQL, you have a front end, you have typical application. You want PostgreSQL and the application to talk directly because they're on the same admin.
No. So a CNI defines a network, and then network policy that a CNI implements enforces policy for everything that's on that network. If something can get into a pod that's not on that network, they make the same decision that we just talked about, A, B, or C. Literally, right? And most CNIs do is say, you can't get on the network, so deny, they make decision B. If you want to get, or you have to write an explicit policy to allow, like node port. So CNIs don't hairpin. I'm pretty sure they mostly blanket deny and say, if you don't want to blanket deny, you have to write an explicit policy to allow this special type of non-CNI traffic to come in.
Yep.
To whatever. And so we could do exactly the same thing. What that special type of policy is and where it comes from, like we can go and noodle on that. But that's it, right? We could hairpin, right, which we spent quite a lot of time thinking about, is maybe the most complex thing, and maybe we shouldn't do it. And the policy, by the way, if you want to come into the network through the waypoint, treat the waypoint like a gateway and go to it, right? Make sure your DNS resolves to the waypoint and off you go. So at least from my perspective, I'm inclined to not hairpin ever, and to choose one of A or B.
Or I
maybe
mean,
add a,
potentially support both, and the user makes a decision if they're going
Right.
to allow or deny.
right, a specific policy.
Yeah.
Yeah. And so the question, I think, what would the default, probably the most important question is, what's the default? Allow all or deny all? By default. But we should probably let users choose. My instinct is to say by default it's allow all, because otherwise we break everything.
I think for the demo profile, if you're deploying this in production, I actually don't necessarily think that's true.
I think we should make you make a choice.
Yeah.
About that.
Fair.
There is no
So
default.
by default, no traffic, just death. Just
Just death to traffic.
503s everywhere.
Sweet.
503 server disconnected, Envoy.
Well, it's the Z tunnel, so it'd just be a drop.
Yeah, I know.
Get a
I
response code.
was just joking. Yeah, I know.
Yeah.
That makes sense, especially as people onboard one namespace at a time. Like you can't. You have to label each of those namespaces separately. That's like the largest granularity we support for opting into layer 4, I think. So the fact that those have to be done one at a time tells me if you have any cross namespace traffic, you've got to have an allow policy for onboarding.
Probably, yes.
Unless you're doing like a blue-green cluster model where you can not actually be processing traffic during your onboarding period.
Yeah, and that's not even accounting for stuff outside the clusters, right? Like, heaven forbid you used a VM these days.
Yeah, I also think that like the other option here is, for instance, and we've talked about this briefly, but like something like Cilium, right? They have this concept in their identity framework called like world, right? Which I'm not necessarily in agreement with this, but basically you are allowed to make decisions on a workload by workload basis about whether or not this quote unquote world identity is allowed to access you. So whether you're allowed to egress to world, ingress to world, right? I'm not necessarily agree with that, but that's potentially a way to think about how we could apply policy of this kind in a targeted way.
I mean, we have with
said a
Alt-
dirty
yeah,
word, but
I think with the Alt-Z framework already, you could say something effectively like that. Right, where principal is unknown, right? That's the same as world.
yeah, principal unknown. Yeah.
Okay,
Right.
Keith,
So we could use that as like an implicit way of talking about it. Yeah. Or and with sane defaults. Not sure.
okay, Keith isn't here, and he was the one who spent quite a bit of time on hairpinning. So maybe and he's on vacation out of the office this week.
I think that's right.
Yeah, that's till the end, till the beginning of next week.
Okay. So maybe we should move this over to a Slack thread and ping Keith, and maybe note that most of the people in this call maybe don't like hairpinning.
Is the ZTAL like hairpinning doc that I shared in the chat, is that still like the basis for the discussion on hairpinning, or is there some sort of doc for a basis for hairpinning? I'm just curious.
No, I think that's still probably the most refined doc, Jackie.
Okay.
Yeah, I think there's still just the basic principles of it and the consequences of that, right? At a high level, those are because it is complexity, right? And like absorbing that. Man, Istio has had a hell of a time absorbing and then unabsorbing complexity over the years.
There was already like a 500 reply thread on hairpinning. Do we just want to revive that?
Oh God, yes, that one.
John would love it.
Mitch, go read you asked the question, go read the 500 reply thread on Slack.
But it worked. We finally agreed not to do hairpinning, so I think that's it's sad that it took 500 messages, but we got there.
That's still cheaper than supporting it and then unsupporting it in production after 3 years.
Oh, yeah. And also traffic going back and forth. And
Bad traffic. Okay. But we still have some open questions about the best way to write the policy, right? To allow world or disallow world, right? I think that's still evolving a little bit. All right, we're over time. I'm rambling. Mitch, you're not allowed to ask any more questions because each one will lead down a rabbit hole. A good rabbit hole, but it would go there. So you can schedule yourself for next week's. How about that? All right, thanks everyone.
Thanks. Cheers.